Once you are done preparing your stormwater management design, so you have your sewer system, you have a control, you have storage, the next step is to export all of these supporting calculations, just like we did for the storm sewer design sheets. Again, it's pretty easy. You come up here, you click on export, and then the second one where it says rational storage design sheets. This is going to prompt you to save the file. We're just going to call this swim tables. And again, this will have created a new Excel file for us. And it's going to populate it with a whole number of sheets in here. The first one is a table of contents, where it's going to break down all of the supporting calculations by the scenario that they belong in. So you've got several here that are part of all scenarios. Here we have, for our existing scenario, we just had the unmitigated peak flows, whereas our proposed scenario, we had the unmitigated peak flows, and we also had all of the flow that was being controlled by our orifice. You'll notice here it says storage group controlled by orifice number 1. This is where you might have had multiple orifices. You might have even multiple different control storage groups, and all of those will appear in here with the supporting calculations. If we go through these quickly, the first one is the peak flow summary. So these results, again, are being fully recalculated in the Excel file, but they're going to match the results that we have in the project. So if I just show you here, you can see 119 compared to 119. So it's exactly replicating these results. On the second page, it's detail. So you can actually see for each scenario, what is the breakdown of contributing flows. Here under mitigated for proposed, you can see it's just a controlled discharge. However, if we had added any unmitigated catchments, it would also show up here. We've got the IDF data. We've got our unmitigated peak flows. This is for the existing scenario as well as the proposed scenario. And so for each catchment, it's going to provide the breakdown of land uses as well as the peak flows. If you had any R modifier values, it will account for that in here. And then we get into this table, which is the storage group summary. Again, it's going to indicate which control is providing the control for the storage group and the corresponding scenario. And you can see here associated control devices. It's telling us exactly which control and the location of that. And keep in mind, you might have multiple orifices or weirs at the same location. InterHyd can account for that. This is going to list all of the contributing unmitigated catchments, as well as any contributing constant flows. So this could be either constant flows that you have defined in your system. This could be a groundwater or a pumped discharge, as well as any discharge from upstream storage areas. So if you've got rooftop detention and discharge from that is coming into this downstream storage group, those peak flows are going to be accounted for here. And then this final table is just the storage discharge summary. So for each event, the high water levels, inflows, discharge from each control. Again, you might have multiple here, as well as the flow out and the storage volumes that are required and provided. We then have more supporting tables for each of your control devices. Those will all be provided here, as well as all of your stage storage curves. And then these set of tables, this is the modified rational method. In this case, it's just the critical storm duration, and it's going to determine which duration results in the highest peak flow. Now, just a quick note on this: the modified rational method, there are various sub methods, I guess you can call them. We do support a number of them. If you go under projects and IDF data, you'll see down here at the bottom it says the stormwater management required storage parameters. There are 3 different methods that we support. They're all slight variations of each other. If you export to all 3, you can actually see the breakdown of the calculations directly in Excel and pick the one that best matches your current practice. And then moving on to here, so there would be a table for each event. You can see here's the 5-year, 10-year, etc. Moving on to the next set here, this is going to be the storage volume that's actually provided. So InterHyd is going to calculate the optimal high water level for every single event. and it's then going to calculate what is the corresponding storage in all of the structures. So things like your pipes, manholes, and all the way down to the actual storage areas that you've defined with the stage storage curve, all of those will be provided. And then here we see total storage volume, 204.9. Again, that will match what we have in the program, 204.9 for the 2-year storm. So once you've reviewed this and you're happy, all you need to do is you will right click, you say select all sheets, then you can use Control P to print everything. When you print, you have to set the scaling here to fit sheet on one page. And then what it's going to do is just make sure all the pages in the corresponding sheets are going to print on one page. You set your printer, and then you do print. Let me just go to our tutorials. And then here we can just name this swim tables, like that. And once it finishes printing, if we come back in here, you'll see we have a new PDF. And you can open this, and you'll see all of the PDF tables are formatted and ready to include with your report. Here you can see we are specifying your company name, the project number file, as well as the appendix title. That can be customized. If we come back in InterHyd, you simply do that under project and project info. And this is where you can customize that data. And so this is a very quick and easy way that all of the supporting calculations you can export and directly include in your appendix.